good day everyone! Understanding the various concepts can greatly enhance our comprehensions of how different elements relate to one another. A prime example of this is the person-hour correlation, a simple yet incredibly effective tool for analysis. It enables us to assess whether two variables or things are connected or dependent on each other. This straightforward mathematical principle can be easily conveyed without requiring complemented formulas and experiments, making it accessible for anyone to browse.
In the world of quantitative research, understanding relationships between variables is important to come up with meaningful conclusions. Pearson's correlation coefficient, often denoted as R, is a powerful statistical tool that helps researchers quantify the strength and direction of a linear relationship between two continuous variables. Before we find out what it is, let's first identify who the proponent is. Carl Pearson was born on 1857 and died in 1936. He created the Pearson's product moment correlation coefficient. He has been credited with establishing the discipline of mathematical statistics. He is also a proponent of eugenics, routine, and biographer of Francis Galton. In collaboration with Galton, founded the now prestigious journal Biometrica. Next slide. The definition. Correlation is a statistical tool to measure the association of two or more quantitative variables. What do you mean by correlation? Correlation is the way of how two variables or more than variables are linked. And when we say quantitative variables, these are the data that we can measure using the information we have gathered. Correlation is also defined as the measure of the linear relationship between two random variables x and y and is denoted by R. So our x here is the independent variable and the y is the dependent variable. And person R is denoted by R. Next, there are 3 degrees of relationship or correlation between two variables. The first one, we have perfect correlation, positive and negative. Number 2, some degree of correlation, positive and negative. And the last one is no correlation. The quantitative interpretation of the degree of linear relationship existing is shown in the following range of values. So here we have different interpretation that we can use.
The importance of person-hour in quantitative research. The person-hour correlation coefficient is also an inferential statistic, meaning that it can be used to test a statistical hypothesis. Specifically, we can test whether there is a significant relationship between two variables. Therefore, Pearson's R is a crucial statistical measure quantifying the linear association between two continuous variables. This is important for data analysis, absolutely crucial in quantitative research. Pearson R is a bridge between collecting raw data and drawing meaningful conclusions. Without proper data analysis, quantitative research findings would be unreliable and uninterpretable. Pearson R, also known as a Pearson correlation coefficient, is a fundamental statistical measure in quantitative research. It quantifies the strength and direction of a linear relationship between two continuous variables. Understanding its importance lies in its ability to reveal insight about the data and guide researchers in various aspects of their study. 2 main reasons why Pearson R is important in quantitative research. Number 1. Testing hypotheses. Quantitative research often involves formulating hypotheses about the relationship between variables. Data analysis techniques like Pearson R are used to test this hypothesis, determining whether the data support or refutes them. Number 2. Measuring relationship. Quantitative research often focuses on measuring the extent and direction of relationship between variables. Data analysis provides the tools like Pearson's R to quantify this relationship. Quantitative research often aims to measure how strongly and in what direction variables relate. Pearson's R is a tool that gives a numerical value to this relationship. Therefore, Pearson R is essential for quantitative research because it helps us identify whether our prediction is true and accurate to our research. Also, we can exactly tell if the research is strong and has a relationship between our two variables. Without this, our research wouldn't be reliable.
So the purpose of person-product moment correlation coefficient, where R measures the strength and the direction of the linear relationship between two continuous variables. Its values ranges from -1 to +1, where -1 indicates the perfect negative correlation, and +1 indicates the perfect positive correlation, and the 0 indicates no correlation. Researchers use it to assess relationship between variables, such as the connection between study time and exam performance, aiding in prediction and analysis.
Pearson's R, also known as the Person-Product Moment Correlation Coefficient. It is a fundamental statistical measure used to assess the strength and direction of the linear relationship between two continuous variables. Here are the key features of the Pearson's R. The definition and formula. Pearson's R is a numerical value that ranges from the -1 to +1, where the +1 indicates a perfect positive linear correlation. Then the -1 indicates a perfect negative linear correlation. And lastly, 0 that indicates no linear correlation. The formula for calculating Pearson's R involves the covariance of the two variables and their standards. It is given by interpretation. In magnitude, the values closer to +1 or -1 represent stronger correlations. The values closer to 0 indicate weaker correlations. In direction, a positive value indicates a positive correlation. A negative value indicates a negative correlation. For guidelines, the strong correlation R is greater than 0.5. Moderate correlation 0.3, less than R, and not equal or greater than 0.5. Weak correlation 0 less than R is not equal or less than 0.3. No correlations R is equal. Application. Commonly used in the various fields like psychology, economics, engineering, and medicine. It helps to understanding relationship, making predictions, and decision making. Calculation and hypothesis testing. The calculations involves finding the mean of each variables, computing the differences, summing products, and standard deviations. Hypothesis testing can determine if the correlations observed is statistically significant in the population. Interpreting results. A correlations matrix can summarize correlations between multiple variables. A correlation close to +1 indicates a strong relationship. A correlation close to 0 suggests weak or no relationship between the variables. In conclusion, Pearson's R is a powerful tool for quantifying relationship between variables. But it is essential to understand its figures, assumption, and interpretation to use it effectively in a data analysis and decision-making process.
So let's go on with the examples of person-product moment correlation coefficient.